are the curves obtained when a plane cuts the cone. A cone generally has two identical conical shapes known as naps. We can get various shapes depending upon the angle of the cut between the plane and the cone and its nap. Ellipse is a conic section that is formed when a plane intersects with the cone at an angle. The point of intersection of the principal axis and the conjugate axis is called the center of the ellipse. Principal axis is also called major axis and conjugate axis is also called minor axis. The axis passing through the center and foci of an ellipse is its principal axis and is also referred to as the major axis. The axis drawn perpendicular to the principal axis and passing through the center of the cone is the conjugate axis. The conjugate axis is also its minor axis. The point on the axis where the section cuts the axis is referred to as the vertex of the cone. There are two vertices for ellipse and they lie at the extreme ends of the major axis. Co-vertices are the points at the extreme ends of the minor axis. There are two co-vertices for ellipse. An ellipse is defined as the set of points where the total distance from two fixed points is always the same and the two fixed points are called foci of ellipse. In other words, the total distance of any point on ellipse from these points is always constant. The latus rectum of an ellipse is a straight line that passes through both foci of the ellipse and is perpendicular to the ellipse's major axis. The latus rectum is also known as the focal chord and it runs parallel to ellipse's directrix. The term latus rectum comes from the Latin word latus, which means side, and rectum, which means straight. This is the full-blown diagram of ellipse, and in this diagram you will find all important parts of an ellipse. In this video, we are going to take up 11 questions of different types based on the properties of an ellipse and work on their solutions. The first question is, if A and B are semi-major and semi-minor axes of an ellipse whose center is at a point -3, 4, what is the equation of this ellipse? The general equation of an ellipse is x square by a square plus y square by b square equals 1, where a is length of semi-major axis, b is length of semi-minor axis. In this equation, the center is located at the origin 0, 0. If the ellipse is moved to a new position with point P, Q as center, the equation of the ellipse gets modified as x minus p whole square by a square plus y minus q whole square by b square equals 1. In the question, the center is moved to -3, 4. Therefore, the equation of the ellipse is x minus -3 whole square by a square plus y minus plus 4 whole square by b square equals 1. On simplification, you will get x plus 3 whole square by a square plus y minus 4 whole square by b square equals 1. The second question is, if the distance of the focus from the center is equal to semi-minor axis B, what is semi-major axis length in terms of B? The equation for focus length is C equals square root of A square minus B square, where A is semi-major and B is semi-minor axis, C is focus length. In this equation, it is given that C equals B. Therefore, the above equation can be rewritten as B equals square root of A square minus B square. Therefore, 2B square equals A square. In other words, length of semi-major axis A equals B square root of 2. The third question is, if A is semi-major axis and B is semi-minor axis of an ellipse, what is the area of ellipse that is not enclosed by the triangle? Area of ellipse equals pi times AB. We have to find the area of the triangle. Area of the triangle is equal to half base into height. B is equal to distance between foci, which is equal to 2 times C, which is equal to 2 times square root of A square minus B square. Height is equal to B. Area of the triangle equals half 2 times square root of A square minus B square multiplied by B. Therefore, area of ellipse not enclosed by triangle equals pi times AB minus B square root of A square minus B square. The fourth question is, if A is semi-major axis and B is semi-minor axis of an ellipse, what is the area of ellipse that is not enclosed by both the circles if center of circles lie at foci? Radius of the circle equals A minus C. Therefore, C equals square root of A square minus B square. Therefore, radius of the circle equal to A minus square root of A square minus B square. Area of both the circles equal 2 times pi multiplied by A minus square root of A square minus B square whole square. Area of the ellipse equals pi times AB. Therefore, area of ellipse not enclosed by both the circles equals pi times AB minus 2 pi multiplied by A minus square root of A square minus B square whole square. The fifth question is, consider an ellipse with semi-major axis E and semi-minor axis B. A point P is located on the ellipse such that the angle between the line segment joining P to the center of the ellipse and the major axis is theta. Derive the coordinates of the point P in terms of A, B and theta. Let us derive the coordinates of the point P on the ellipse in terms of A, B and theta. For an ellipse centered at the origin with semi-major axis A along the x-axis and semi-minor axis B along the y-axis, the parametric equations are x equal to A cos theta, y equal to B sin theta. Here theta is the angle between the line segment joining P to the center of the ellipse and the major axis. Therefore, the coordinates of the point P are A cos theta and B sin theta. The sixth question is, what is the eccentricity of an ellipse? What is the equation for eccentricity? The eccentricity of an ellipse denoted by E is the measure of how much ellipse deviates from being a circle. It is defined as the ratio of the distance from the center of the ellipse to one of its foci to the length of the semi-major axis A. Therefore, E equals C by A. Here C is given by square root of A square minus B square, where A is the length of the semi-major axis and B is the length of semi-minor axis. The value of E ranges from 0 to 1. If A equals 0, it is a perfect circle. If A is close to 1, the ellipse is more elongated. The seventh question is, an ellipse has its foci at 5, 0 and the length of its major axis is 14 units. Calculate the eccentricity of the ellipse. Given values are the distance between the foci is 2c, which is equal to 10. The length of the major axis is 2a equal to 14, so a equals 7. Use the relationship between a, b and c. C square equals a square minus b square. Substitute the known values to find b, where c equal to 5 and a equals 7. Therefore, b equals square root of 7 square minus 5 square equal to 2 square root of 6. Calculate the eccentricity E equal to c by a equal to 5 by 7. Therefore, semi-minor axis is 2 square root of 6 and the eccentricity of the ellipse is 5 by 7. The eighth question is, what is the latus rectum of an ellipse? The latus rectum of an ellipse is a line segment that passes through one of the foci and is perpendicular to the major axis. It is also known as the focal chord that is parallel to the directrix of the ellipse. The ellipse has two latus rectums, one for each focus. For an ellipse with a standard equation x square by a square plus y square by b square equals 1, the length of the latus rectum is given by 2 times b square by a. The properties of the latus rectum are: the latus rectum is always perpendicular to the major axis of the ellipse. The second property is it passes through the foci of the ellipse. Third property is the endpoints of the latus rectum lie on the ellipse. And the fourth property is it is parallel to the directrix of the ellipse. The ninth question is, for an ellipse with a equals 5 and b equals 3, what is the length of the latus rectum? For an ellipse with the standard equation x square by a square plus y square by b square equals 1, the length of the latus rectum is given by 2 times b square by a. Substituting the values of a and b, you will get length of the latus rectum equals 2 times 3 square by 5 equal to 18 by 5 equal to 3.6 units. The 10th question is, an ellipsoid with a equals 5 and b equals 3 and c equals 4 units is enclosed in a sphere of radius 5 units. What is the volume of the sphere that is not enclosed by ellipsoid? Volume of the sphere is 4 by 3 pi r cube, which is equal to 4 by 3 pi times 5 cube, which is equal to 500 by 3 pi. Volume of ellipsoid equals pi times ABC, which is equal to 60 pi. Therefore, volume of sphere not enclosed by ellipsoid equals 500 by 3 pi minus 60 times pi, which is equal to 320 by 3 pi. The last question is, a point P on an ellipse has a distance of 8 units and 6 units from foci. If foci are at a distance of 5 units from center, calculate semi-major and semi-minor axis. As per definition of ellipse, if distance of point P is 8 units and 6 units from foci, total sum of these distances equals 2 times semi-major axis. Therefore, 2a equals 8 plus 6 equal to 14 units. Therefore, a equals 7 units. If c equal to distance of focus, b equals square root of a square minus c square. Therefore, b equal to square root of 7 square minus 5 square equal to 2 square root of 6. With this exercise, we are ending this session. Thank you for watching.